We've always thought of planets as members of a solar system, loyal to a sun part of a cosmic family. But what if I told you there are billions upon billions of planets that have no star to call their own? Planets that drift alone through the endless black of interstellar space, no sunlight to light their skies, no orbit to follow, no home to return to. These are rogue planets, the free-floating wanderers of the cosmos, the loneliest worlds in existence. For most of human history, we had no idea they were real. They were just a theoretical ghost in the equations of astrophysics, a what-if scenario for astronomers. But over the past 2 decades, cutting-edge telescopes, space missions, and cosmic surveys have turned this theory into fact, revealing that these solitary planets are not rare oddities. They are one of the most common types of planetary bodies in the Milky Way galaxy. Today, we're going to journey into the dark, silent realm of rogue planets, uncover how they form, how we find them, what they look like, and what their existence tells us about the vast uncharted universe we live in. This is the untold story of the cosmos' forgotten wanderers. First, let us define exactly what a rogue planet is. Also called free-floating planets, nomad planets, or interstellar planets, a rogue planet is a planetary mass object that does not orbit any star, brown, dwarf, or other central celestial body. It is bound only to the gravity of the galaxy itself, drifting through the space between stars, moving silently through the cosmic void for billions of years. Unlike the planets in our solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, all of which circle the Sun in stable, predictable paths, rogue planets have been cut loose from their cosmic roots. They are orphans of the stars, cast out into the dark to wander alone. You might be wondering, how big are these worlds? The answer varies wildly. Some rogue planets are small rocky worlds, roughly the size of Earth or Mars, known as terrestrial rogue planets. Others are massive gas giants, many times the size of Jupiter, the largest planet in our solar system. A few are even so large that they blur the line between a planet and a brown dwarf, a failed star that never gained enough mass to ignite nuclear fusion in its core. But no matter their size, all rogue planets share one defining trait: they are free, unshackled from the gravitational pull of any star. The story of how we discovered rogue planets is a tale of scientific persistence and technological breakthrough. For nearly 200 years, astronomers had mathematical reasons to believe such planets might exist. Models of solar system formation showed that when young solar systems are first taking shape, they are chaotic, violent places. Planets smash into each other, gravitational tugs between giant worlds send objects flying, and the delicate balance of gravity can easily fling a planet entirely out of its home system. But for centuries, we had no way to see these dark, lonely worlds. They emit no visible light of their own, and they don't reflect the bright glow of a parent star, making them nearly invisible against the black backdrop of deep space. They were cosmic ghosts, impossible to detect with the telescopes of the past. All that changed in the early 1990s, when astronomers began discovering the first exoplanets, planets orbiting stars outside our solar system. The Kepler Space Telescope, launched by NASA in 2009, revolutionized exoplanet science, finding thousands of worlds by watching for the tiny dips in starlight as a planet passes in front of its star. But Kepler was designed to find planets that orbit stars. It could not spot rogue planets which have no star to cross. Then, in 2012, a team of astronomers, using ground-based telescopes in Japan and Chile, made a groundbreaking announcement. They had detected the first confirmed rogue planets floating freely in the Milky Way. Using a technique called gravitational microlensing, they observed how a rogue planet's gravity bent and magnified the light of a distant background star, creating a temporary brightening that revealed the planet's presence. This was the first concrete proof that rogue planets were real, not just a theory. Since that 2012 discovery, the hunt for rogue planets has exploded. NASA has poured resources into studying these worlds, and the James Webb Space Telescope, the most powerful space telescope ever built, has become our greatest tool for unlocking their secrets. Webb's infrared vision can detect the faint heat signatures of rogue planets, even in the darkest corners of space, allowing astronomers to measure their temperature, study their atmospheres, and learn about their composition. Recent surveys, led by NASA and the European Space Agency, ESA, estimate that there are billions of rogue planets in the Milky Way alone. Some studies suggest there could be as many as one rogue planet for every star in our galaxy, or even more. That means there are more wandering planets than there are stars shining in the night sky. Think about that for a moment. our galaxy, with 100 to 400 billion stars, is teeming with billions of dark, lonely worlds that we are only just beginning to find. This changes everything we thought we knew about planetary populations. For decades, we assumed most planets lived in solar systems like ours, but the data now tells us that the majority of planetary mass objects in the Milky Way are rogue planets, floating alone in the dark. So how do these planets end up as cosmic wanderers? There are two main ways. A planet becomes a rogue world, and both are tied to the violent chaotic process of solar system formation. The first and most common origin story is planetary ejection. When a new solar system is born, it forms from a giant cloud of gas and dust, called a protoplanetary disk. Over millions of years, tiny dust grains stick together to form rocks, then asteroids, then full-sized planets. In these early days, the solar system is a crowded, dangerous place. Gas giants like Jupiter and Saturn exert immense gravitational force. If a smaller planet gets too close to one of these giants, or if two giant planets interact with each other, the gravitational tugs can become catastrophic. The smaller planet is sent flying on a chaotic path, gaining so much speed that it escapes the gravitational pull of its parent star entirely. It is like a game of cosmic billiards, where one wrong move sends a planet hurtling out into interstellar space, never to return. This process is incredibly common in young solar systems. Astronomers believe that our own solar system may have ejected one or more planets in its early days, a lost world that now drifts as a rogue planet, somewhere in the Milky Way. The second way rogue planets form is in situ formation, meaning they are born as free-floating planets from the start. Some clouds of gas and dust in space collapse to form planetary mass objects, but never gather enough material to become a star or a brown dwarf. These objects form in isolation, with no parent star to orbit, born as wanderers from the very beginning of their existence. They are not ejected from a solar system, they were never part of one at all. This makes them even more mysterious, as they represent a completely different class of planetary object, one that defies our traditional definitions of how planets are made. What are these rogue planets like? What would it be like to stand on one? For most rogue planets, the surface is a world of eternal darkness and extreme cold. Without a star to provide heat and light, the skies are black, dotted only with distant stars and the faint glow of the Milky Way. Temperatures on most rocky rogue planets plummet to hundreds of degrees below zero, cold enough to freeze gases like nitrogen and oxygen into solid ice. Gas giant rogue planets, however, can be surprisingly warm. Deep within their thick atmospheres, gravitational compression and residual heat from their formation generate internal warmth. Some gas giant rogue planets have been found to have temperatures above freezing, with thick, cloudy atmospheres and liquid layers beneath their frozen surfaces. This has led to one of the most exciting questions in astrobiology: could rogue planets support life? For a long time, scientists thought life was impossible on a planet without a star. Life as we know, it needs liquid water, energy, and organic molecules, and we assumed starlight was the only source of energy. But rogue planets challenged that idea. A thick atmosphere could trap internal heat from the planet's core, creating a habitable layer beneath the clouds, even with no sunlight. Hydrothermal vents on the ocean floor, powered by geothermal energy instead of starlight, could provide the energy needed for microbial life to evolve. This means rogue planets, the loneliest worlds in the cosmos, could actually be hidden havens for life, scattered across the galaxy by the billions. It is a mind-blowing possibility that redefines what we think of as a habitable world. The study of rogue planets also teaches us profound lessons about the universe and our place in it. For centuries, humans have viewed Earth as a stable, safe world, part of a gentle solar system, orbiting a calm star. But rogue planets remind us that the cosmos is a dynamic, chaotic, and often unforgiving place. Planets are not permanently bound to their stars. They can be cast aside, left to wander the dark. They also show us that the universe is full of surprises. The things we once thought were impossible, planets without stars, worlds with no sunlight, life in the darkest corners of space, are not only possible, but common. Every time we discover a new rogue planet, we expand our understanding of planetary science, solar system formation, and the limits of what a planet can be. NASA's ongoing missions, including the James Webb Space Telescope, are continuing to hunt for rogue planets, cataloging their sizes, temperatures, and compositions. Future space telescopes, currently in development, will be even more powerful. able to map thousands of rogue planets and study their atmospheres in unprecedented detail. We are on the cusp of a new era in rogue planet research, one that will uncover even more secrets about these mysterious wanderers. As we look out into the cosmos, at the trillions of stars and the billions of planets that circle them, we must also remember the countless rogue planets drifting silently between the stars. They are the forgotten worlds, the orphans of the galaxy, yet they hold some of the greatest secrets of the universe. They remind us of the vastness of space, the unpredictability of cosmic forces, and the endless wonder that waits to be discovered beyond our solar system. The universe is far stranger, more diverse, and more amazing than we ever imagined, and rogue planets are just one piece of that infinite puzzle. Every time we peer into the dark, we find something new. Every time we ask a question about the cosmos, we uncover a story more incredible than the last. Rogue planets are not just celestial objects, they are a testament to the beauty and mystery of deep space, a reminder that the universe is full of worlds we have yet to imagine. As we keep exploring, keep searching, and keep looking up at the stars, we will continue to find these lonely wanderers, and in doing so, we will learn more about our place in the endless, awe-inspiring cosmos. Please like, comment, share, and subscribe to the channel